How can a thin metal plate tell you the flow inside a closed pipe? It cannot do that alone. The plate creates a pressure difference, and a differential pressure transmitter measures that effect. By the end, you will see the complete chain from restriction to delta P to an indicated flow value, and why a healthy transmitter can still show the wrong flow. An orifice plate is a thin plate with a precisely sized bore installed between pipe flanges. Fluid must pass through the smaller opening, so it accelerates. Static pressure is higher upstream and lower downstream. Pressure taps sense these two conditions. Their difference is differential pressure, written as delta P. The plate is the primary element. It creates the measurable effect, but sends no electrical signal. The fluid jet keeps narrowing after it passes through the bore. Its smallest area is called the Vena Contracta. Velocity is highest and static pressure is lowest near this region. Farther downstream, the stream expands and some pressure recovers, but not all of it. Turbulence and mixing create permanent pressure loss. The lowest pressure is therefore not simply located on the plate face. The upstream tap connects to the transmitter high side, and the downstream tap connects to the low side. Impulse lines carry process pressure through a valve manifold to the sensing diaphragm. The transmitter measures high pressure minus low pressure. Its electronics, or the control system, then apply the configured flow calculation. The manifold routes and equalizes pressure. It does not calculate flow. For a fixed plate and stable fluid conditions, differential pressure changes approximately with the square of flow. Flow is therefore proportional to the square root of differential pressure. At 25% dP, indicated flow is 50%. For times the dP represents about twice the flow, not 4 times. Square root extraction must be applied once, inside the transmitter or in the control system, depending on configuration. Quick check. Differential pressure increases from 25% to 100% of its calibrated range. Does flow become 4 times larger, 2 times larger, or stay unchanged? Think about it. The answer is 2 times larger. The dP ratio is 4, and the square root of 4 is 2. This simplified example assumes the fluid properties and design conditions remain unchanged. A calibrated transmitter does not guarantee accurate flow. A plugged impulse line, leaking equalizing valve, trapped gas or liquid, damaged or reversed plate, protruding gasket, disturbed flow profile, or changed fluid density can bias the result. A stable reading can still be wrong. Before field work, always follow plant SOP, PTW, isolation, depressurization, venting, draining, PP, LODO, and supervisor instructions. Never loosen a fitting to test for blockage. The complete chain is now clear. The orifice plate creates a restriction. Flow produces a pressure difference across that restriction. The high and low pressure pads reach the dP transmitter. Square root extraction converts measured dP into indicated flow. Reliable measurement also depends on the plate, process conditions, impulse lines, manifold, transmitter, and control system configuration. Thanks for watching, and subscribe for more industrial instrumentation lessons.